Hello, I'm Hiroshi Shibako, General Manager of Technical Solutions Department of ClassNK. Various approaches are being made toward decarbonization. Wind-assisted propulsion has recently received increasing attention. The picture at the left shows the world's first automatically controlled sailing ship built in Japan in 1980. Another one is the rigid wing sail project called Wind Challenger by Japanese players. ClassNK issued AIP for this concept in 2019. Within these 40 years, the wind-assisted propulsion technologies have well been progressed. Before starting my presentation, I would like to express my respect to the pioneers who have tackled many technical challenges to reach the technology. As wind-assisted propulsion is a technology influenced by natural phenomena that human beings cannot control, I should say its CapEx and OpEx will remain the biggest challenge for widespread adoption. Meanwhile, the technical and safety challenges for the installation and operation have been mostly identified, and the necessary countermeasures have been established. Today, on this occasion, I'd like to introduce what should be considered to utilize the wind-assisted propulsion system, so-called WAPS, on board from a technical point of view. I briefly outline the typical type of wind-assisted propulsion system. Firstly, rigid sail. The sail of the wing-like cross-sectional shape generates lift by capturing the wind. The control of the sail angle, spreading, setting can be operated according to the wind speed and direction. With no deformation on the sail surface by wind, it can always maintain the optimal wing shape. A coal carrier equipped with the world's first FRP-based hard sail was delivered to MOL in October 2022. MOL presented at a seminar last year that they plan to confirm the effectiveness of the sail during the demonstration test until the end of March 2024. On its maiden voyage from Japan to Australia, the performance was high when all 4 stages were deployed, and the deduction effect of about 8% was confirmed in the low speed range. Secondly, the rotor sail. This is a cylindrical device that rotates at high speed, but not by the cross-sectional shape approach. It obtains lift by the Magnus effect, a phenomenon in which lift is generated in direction perpendicular to the flow when the rotating cylinder or sphere is in a uniform flow. The rotation speed is controlled according to the wind speed and direction. High lift coefficient can be achieved by the rotating mechanism. It has a simple structure, and collapsible types are also available. Currently, rotor sail is the most widely adopted. It is reported that the reduction effect of 5 to 10% after subtracting the energy required for the rotating the device is expected in recent installation plans. Thirdly, two-wing kite. A kite is deployed from the bow of the ship forward, and it generates propulsion power by catching the wind and pulling the ship. The kite flight is automatically controlled, and its launching and storing are also automated. It can utilize stronger wind at higher altitude. In March, K-Line specified the coal carrier to retrofit the system. They expect the reduction of CO2 emission by at least 20%. Finally, turbo sail or suction wing. It controls the boundary layer around the device and generates lift, not with the rotating mechanism, but by using movable flaps and a suction mechanism. The suction mechanism and the flaps are controlled according to the wind speed and direction. A higher lift coefficient can be achieved by the suction mechanism. As well as the rotor cell, the structure is simple, and they are collapsible type. Marubeni Corporation Japanese trading house announced a joint project with partners for its installation on Panamax bulk carrier, and expected the reduction of up to 15 to 20%. For implementing these systems, class societies provide safety standards and certification based on them. Standards are to be applied to the safety of the system itself and the safety of the base ship where the system is installed. Moreover, from an environmental perspective, as the international rule for reflecting WAPS into EEDI and EEXI had been stipulated, class societies also work on its verification. We anticipate the need for third-party certification of its effect from the commercial or ESG perspective. We believe that our expertise can be utilized in meeting these needs. Let me explain the specific verification steps. For the system's design, we review drawings and conduct on-site surveys. Once compliance with the prescribed criteria is confirmed to the wind-assisted propulsion system, we issue product certificate. When installing the system on a ship, we review the design and conduct surveys for installation as well. Upon request, we grant class notation. In case of ClassNK, notation is optional, but periodical survey are required if applied. As WAPS is likely to include a new concept, we may also issue approval in principle as needed. We have published the standard for system and its installation and operation as guidelines for wind-assisted propulsion systems for ships, issued the first version in 2019. Thanks to opportunities to be involved in actual projects in recent years, we have incorporated feedback from our experienced drawing reviews and surveys, as well as recent trend, and updated to edition 2 in this April. We are confident that the latest version has been significantly improved in terms of clarity, comprehensiveness, and level of detail. The principal safety philosophy of the guidelines is based on the functional requirements and risk assessment. Functional requirements include safety and reliability of the systems, safety and reliability for operation, resistance to failure, protection of personnel and environment, interference with the ship function, and assessment of compatibility. Following the general section, the guideline provides requirements for WAPS-based ships, to which the ship for WAPS is installed and surveys. In view of identifying and mitigating potential risks caused by WAPS installation, which are new and diversified, conducting a risk assessment has been included as one of the requirements. As for specific requirements for the system, we have set requirements in Part A of the guidelines. For example, we have clarified and detailed loads and load cases for the structural design of the systems. 4 kinds of load are anticipated, namely aerodynamic loads, loads due to ship motion, green sea loads, and other loads. There should be 3 load cases, namely in service, standby, and abnormal condition. For each condition of 3 load cases against each kind of load, we have set the criteria, which should have been corresponding to any potential situation. For structural design, we provide yield strength, buckling strength, and fatigue strength evaluations for structural components of WAPS. For driving and control systems, the requirements for electrical systems, hydraulic systems, and control systems for the operational process like rotation, expansion, or contraction, inclination, movement, and storing are provided. For operation and maintenance, we have clarified the items that should be included in the operation manual. For WAPS production certification, after drawing review and surveys during the manufacturing, load tests and operating tests shall be conducted. Regarding the requirements for base ships, attention should be paid to these factors described in Part B of the guidelines. The ship's design should be developed in consideration of the installation of WAPS that contains deck plating and under-deck structure providing adequate support for WAPS. For that, the guideline provides yield, buckling, and fatigue strength evaluation considering the load caused by the WAPS. Hull girder strength is also the factor in consideration of changes in light weight and position of the center gravity also affect ship motion and stability. Especially the intact stability shall be verified with the increase in wind healing moment due to aerodynamic laws acting on WAPS. At maneuverability, the effects of hull heel and leeway should be taken care of. For ship speed, attention is necessary not to reach the service speed greater than the speed corresponding to its engine MCR through a combination of the main propulsion system and WAPS. Then the guidelines stipulate the methodology for the impact of navigation bridge visibility, navigation light, and radio equipment due to the installation of the system. Other matters include the equipment number, electrical installation like power capacity, protection against short circuit, and hazardous area, fire safety, and gross tonnage, and so on. At the Part C of the guideline, the requirement for surveys related to WAPS are provided. After the installation, WAPS is subject to testing and confirmation at periodical class maintenance surveys. I would like to refer typical items for safety consideration. In terms of the arrangement, firstly, it is essential to comply with provisions of the class rule for navigation bridge visibility in consideration of blind sectors caused by the WAPS. For navigation lights, it should certify the provision of color regulation on top of consideration of the seeding caused by WAPS. Depending on the case, confirmation to the flag administration is necessary for these items. Regarding interference with cargo handling equipment or helicopter deck, confirmation for the operation at each port of call is recommended. In reflecting, the installation is likely to bring changes in light weight, longitudinal and vertical center of gravity. In such cases, an inclining test and update of related documents are required. Besides, it is necessary to verify the risk to personal, environment, and the structural strength or integrity of the ship that arise from the installation of the WAPS, both for the system and base ship. Ideally, a risk assessment should be carried out with the participation of stakeholders such as WAPS manufacturer, ship owner, management company, ship designer, and so on. Once specification of WAPS and the specific ship or installation have been determined. The right slide shows the steps of the risk assessment as an example. Preliminary investigation means the investigation of WAPS and the base ship respectively, including the potential arrangement and functions. Preparation for risk assessment meeting involve identifying hazards and impact of the WAPS and base ship. Then, risk assessment meeting attended by stakeholders is held to confirm hazards, impact, prioritizing risk and safety measures, followed by the report based on the meeting outcomes. The risk assessment result, which are supposed to be precautions and additional safety measures, should be appropriately reflected in the design or related manuals. At the risk assessment, the keywords are useful for identifying hazards such as collision, contact, structural damage, equipment, and system failures, operational failures, sudden load from the external environment, and so on. The table illustrates the example of assessment, expecting collapse of lower support of the base ship caused by load by the WAPS, risk control measures of verification of the structural strengths by class rules, and the condition monitoring of the WAPS are implemented. Another one is for the possible damage to WAPS by overload caused by the gust. Strength evaluation considering the impact of gust and introduction of an automatic control system to prevent overload are implemented. Accumulating these kind of steps helps mitigate risks. We hope these tips will help facilitate the introduction of such systems. As mentioned, the uptake the wind-assisted propulsion system is rapidly increasing. We recognize this as a reflection of industry expectations amidst the need for various approaches toward decarbonizing ship operations. ClassNK aims to support smooth implementation by establishing appropriate standards and providing reliable drawing review and survey service in line with them. We also look forward to deepening the dialogue with stakeholders, including these attending ladies and gentlemen today, for future adoption and advancement of the related technologies. Thank you very much for your attention.